I'm skipping to example 4 in the notes. You can follow example 3 and ask me if you have any questions. In example 4, we have the circuit drawn here, and you notice that I've already put in the capacitive and inductive reactances into the circuit. So that means, and I also have the potentials in phasor forms already, which means that this voltage 6 volts for V2 is RMS, and the voltage 5 volts for source V1 is RMS. And we have to assume that both of these voltage sources have the same frequency. If not, we can't do this. So we don't ever have to worry about what that frequency actually is at this point. We could calculate that. But we just know our capacitive and inductive reactances, so we can proceed a little quickly. So let me clear out this here so we can get a good view of what our variables are. So we're given, we have R1 is equal to 15 ohms, R2 is equal to 10 ohms, and R3 is equal to 6 ohms. Our capacitive reactance 1 is equal to 7 ohms, and that would be 7 J ohms, or actually negative 7 J ohms, because it is capacitive. And our inductive, or capacitance 2, it's going to be minus 10 J ohms because of being capacitor. And our inductive reactance for L1 is 18 J ohms. So now these are paired up, and I can create a combination of those two, and I'm going to call that Z1. And then I can make Z2 here, and Z3. So Z1 is going to equal R1 plus XC1, and that's going to be 15 minus 7J ohms. Z2 is going to be R2 plus XC2, and that's going to be equal to 10 ohms minus 10J ohms. And Z3 is going to equal R3 plus inductive reactance 1 for inductor 1, and that's going to be 6 ohms plus 18 J ohms. So now it's really a good idea to use the memory in your calculator. It makes this a lot easier to store these variables, and then all you have to do is type the variable names instead of having to type all of this information in. believe me, it has saved me a number of times. And it's much easier if you mess up to go back and fix the equation than having to type all of this back in. So now that we have our impedances, we'll be able to get ready to do our circuit analysis using Kirchhoff's voltage law and Kirchhoff's current law.